So today we're going to look at prime factors. You looked at prime numbers last lesson, and now we're going to look at how a number can be written as a product of prime factors. Every number can be written as a product of its prime factors, and we can use a factor tree to find that. So product meaning a multiplication. Write 24 as a product of its prime factors. And we're going to use a factor tree to do that. So firstly, thinking about the number 24, what are two numbers that multiply to give 24? There's a few. Doesn't matter where we start, we will all end up at the same place, and I'll show you that as well. So 24, I'm going to go with 6 and 4, because 6 times 4 is 24. Now 6, what are two numbers that multiply to give 6? They would be 2 and 3. Now once we get down to some prime numbers, we actually put circles around them. So 2 and 3 can't be broken down any further. They are prime numbers. The number 4 is definitely not a prime number. There are two numbers that go into the number 24. Those would be 2 and 2. What that means is that we can write the number 24 as 2 times 3 times 2 times 2. I might put all the 2's together, so 2 times 2 times 2 times 3. Okay. Now we can also write that using index notation. So I could have written that as 2 cubed, because we've got 2 times 2 times 2, and then we've got 3 on the end. Now if you didn't choose 6 and 4 to start with, let's think, are there other numbers that multiply to give 24? What if I'd started with 2 and 12? So typically if it's an even number, it's easiest just to pick the number 2 to go into it. 2 is a prime number, so this part of your factor tree is going to stop here. The number 12, that has a few numbers that can go into it. I'm going to choose 3 and 4. You could go and choose 6 and 2, but again, you will arrive at the same answer. So if I choose 3 and 4, I can't circle 4 because that is not a prime number. 3 is a prime number. So the number 4 has 2 and 2. And you can see that we end up with the same thing again. We've got 2, 2, 2, and 3. Example 2, write 648 as a product of its prime factors using index notation. 648 is a little bit tricky, probably because it's quite a large number. So I can see that the last number is 8, which means that 2 is going to go into that. So I'm going to write that as 2 and something else. Now quickly, this is really easy to divide 2 into it because you can see every single number is even. So 2 into 6 is 3, 2 into 4 is 2, and 2 into 8 is 4. Again, we've got another even number. So without having to think about if there's any other numbers that go into that, I can split that into 2 and something else. And I should be circling these because these are prime numbers. Now, 2 into 324. However way you want to work that out on pen and paper, or if you're really struggling to do that, you can use a calculator. But how I would do it, I would say quickly 2 into 3 goes once with 1 remainder. It's kind of like a sneaky long division. 2 into 12 is 6, and 2 into 4 is 2. We're left with another even number. So let's see what happens if I pull out 2 again. 162. Now, some mental strategies for doing this. Half of 160 is 80. So there's only a 2 left over. So half of 2 is 1. So this will be 81. 81 is an odd number. It's not prime. there is one number that multiplies nicely by itself to give that. It's actually one of our square numbers that we looked at a few lessons ago. So 9 and 9 go into 81. And then also each of these 9s can be broken down into 3 and 3. So we've got all of these prime numbers now to write 648. So 648 would be, we had 1, 2, 3 2s. So 1, 2, 3, and then we're left with 4 3s as well. And we can write that using index notation. So 1, 2, 3 means 2 to the power of 3, and that would be 3, times 3 to the power of 4. One more example, use a factor tree to find the square root and then the cubed root of those two numbers. So 196, if we split that into 2, now 2 into 196, you could use a calculator however you want to do it. 2 into 19 goes 9 times, remainder 1, 2 into 16 is 8. So 98. 98 again is an even number, so 2 and 49. 49 is 7 times 7. 7 is a prime number, so I know that 196 can be written as 2 times 2 times 7 times 7, or 2 squared times 7 squared. Now if we want to find the square root of 196, I want to find the square root of 2 squared times 7 squared. Now if you square something and then take the square root, you're going to get back to the same place that you started with. So if I square 2 and take the square root of 2 squared, I should get back to the number 2. So we'll be left with 2 times 7, which is 14. A little bit trickier, we've got the cubed root here of 216. So 216, 2 goes into that. 2 into that number there, let's say 108. Okay, so you can use a calculator if you want to, but basically that 2 into 2 goes once, 2 doesn't go into that, so then it's 2 into 16, which is the number 8. Again, we've got an even number, so we could pull out 2, and that would be 54. Another even number again, half of that is 25 plus 2, which is 27. 27, 9 and 3, and then the number 9 breaks down again to 3 and 3, which is convenient because we want to find the cubed root of that number, and we've got 1, 2, 3 2s and 1, 2, 3 3s. So 216 can be written as 2 cubed times 3 cubed, and we want to find the cubed root of 216. So the cubed root of 2 cubed times 3 cubed, which is very similar to what we did over here. We'll just be left with 2 times 3, which is 6. Okay, and that's a way to find the square root and cube roots of numbers, sort of without using a calculator, because there is a function on your calculator. We can use our calculator to check. So for example, square root of 196, 14, which is what we got there. And then the cubed root of 216. So the cubed root was here in yellow, so shift press that button, 216, and we get the number 6. Okay.